A warm and cheerful good evening to one and all present here. Today, we have assembled here for the inauguration of IEEE IAS SBC UKF CET Summit 2020 on the occasion of the second anniversary of our double milestone chapter at UKF CET. This will be followed by an expert talk on the topic Vehicle Electrification, Opportunities and Challenges. To start with, I invite Professor Atul MV, the advisor of IEEE IAS SBC UKF CET, for the welcome address. Sir, please.
Thank you, ma'am. A very good afternoon to all. I take this privilege to warmly welcome you all to the first day of IASU Summit 2020 on its second anniversary. Thank you all for your valuable time. I would like to start by wishing you and your families my personal best for your health and safety in these difficult times. I would like to convey my heartfelt condolences to those who demised in yesterday's accidents at Jaipur Airport and natural calamity at Munnar. IEEE IAS SBC UKF CET started 2 years back in 2018 as a double milestone chapter. That is 400th in the world and 50th SBC in India. During these 2 years, we were welcomed with many other golden milestones like winning the prestigious IEEE IAS CMD Most Happening Chapter Contest Award in 2020, AMTGP for representing at IAS annual meeting at Baltimore, USA in 2019. Our event got featured in UN activity website last year, 2 months back. And here we are with our flagship event IASU Summit 2020. It will be conducted in 3 days with eminent, wonderful speakers from electric vehicle and renewable energy sector. It's my great pleasure to welcome our guest of the day and a wonderful human being I know, Dr. Tommy Sebastian, IEEE IAS past president in 2018 and director of motor drive systems at Hala Mechatronics, Michigan, USA. I welcome you, sir.
Thank you.
I heartily welcome our beloved director of UKF CET, Ms. Amrita Prasad, to this occasion. I welcome you, ma'am.
Thank you, Atul.
I welcome Counselor of IEEE SB of UKF CET, Mr. Sumant Sundar, to this occasion. I welcome you, sir.
Yeah, thank you. Thanks a lot, sir.
Lastly, I welcome all the enthusiastic listeners of the day to this occasion. Welcome you all. I wish everyone a fruitful session. Thank you.
Thank you, Professor Atul. Now I invite Professor Sumant Sundar, the Counselor IEEE SB UKF CET, for a special address. Sir, please.
Yeah. So good evening to all. Hope you are all safe and during this pandemic situation, and remembering the brothers we lost in the tragedies yesterday. And this is a very proud moment for our team and personally to me as a branch counselor. And we started our SB in our UKF College by the year 2015. And in the first 2 years, it was really a great takeoff. And it was a wonderful takeoff by conducting a lot of programs and by associating with the society and including programs having active participation across India. And it includes the program that is a hub level program, which are hosted in the campus with 250 plus participants from Kerala. And the happiness was multiplied thrice with the birth of our IAS SBC and ComSoc SBC and the V affinity group in our campus, and we call it as UKF IEEE SB family. Okay, so both these SBCs and affinity group are doing wonderful activities and receiving a lot of appreciation from the section level and national level. And this IAS SBC had some specialties in its birth itself. That is, it's a double milestone chapter. And this 2020 is very special to us because our IAS SBC won this most happening chapter award, which is top in the world, beating 465 chapters across the globe. And definitely it raised our pride to the top of the table. So this second year celebration is very special to us for our IEEE family. So today I should say that we got the most apt person. That is, we could get, that is Tommy Sebastian, sir, and who served as the past president during the year 2017-18. And he's the director of drive systems, Hala Mechatronics, USA. So thanks for accepting our invitation, sir. So without wasting time, I'm getting into my procedure. So I wish my heartfelt thanks to the entire team of IAS SBC and the SB members for the effective and successful completion of the program. So I wish all the best.
Thank you, Professor Sumod. Today's session is presided over by the charming presence of UKF CET, our beloved director, Mrs. Amrita Prashop. On behalf of everyone present here, I invite our director, Mrs. Amrita Prashop, for the presidential address. Ma'am, please.
Yeah, thank you, Suja. So good evening, everyone. Respected speaker of the day, Dr. Tommy Sebastian, and my all dear IEEE UKF family members. I think it would be not nice if I am not starting this presidential address with a story that I have already told in many of the chapter sessions. But then it won't be nice again if I'm not repeating it again, because it was just like Professor Sumod has mentioned, the footsteps that we have taken first for the starting of an IEEE chapter in our college, the people behind that, the tremendous effort they had taken, they are all worth, should say, to be remembered at this occasion. Because it was a long cherished dream from our part to start an IEEE chapter inside the college. But then we had our own hurdles to do that. And the first part was convincing the students about IEEE. What is the importance? What is the benefit they are getting with the subscription they are giving, and all such things. And it was, to be frank, was very difficult to get the first 8 students getting convinced and join the IEEE chapter. And I think the then Professor Anu, who is not in our team right now, but is a good well-wisher of our UK family. He is the one who took the initiative with Professor Shemin, who is already in our team. And then again, it took a big leap when it was the charge was handed over to Professor Sumod, who is right now the counselor of the full team. And then we started seeing a multiple chain effect when students who got into this activities related to IEEE, they started getting benefits, they started getting exposed to a lot of opportunities that the normal students who are not part of IEEE started getting. And then it has reached a level where an IEEE chapter from a very budding college in the state of Kerala has won the most happening chapter award. So this is something that is worth celebrating. If it would have been a normal time, pre-COVID time, as we say right now, it was a very good opportunity for all of us to come, celebrate and cheer. So anyway, let me use this opportunity to have an online cheerful party today, similar to what we should have had in the campus. So we have all the IEEE, especially the IAS chapter members, both students and faculties here. I would like to congratulate and thank you all the IEEE facilitators, especially Professor Sumod, Professor Atul, who is heading the IEEE IAS chapter, and also Professor Shankar, who is taking care of the another chapter. So, and also the office bearers from the student side, Ms. Leah Raj and also Akhil TP, who has been heading the student team to guide the full chapter to win such a laurel. I should say we haven't. I don't know whether it was a goal or something for the Professor Atul, who was heading this chapter, to get the most happening chapter award, but might be he has done the activities pretty well, and then it led to the award. It was a byproduct of the activities that we had done, and it is, of course, pride for us right now. And especially it's a 2-year-old chapter. I still remember the very first day, the inaugural session of the IEEE IS chapter we had with Professor Qasim, and we never thought it would reach this heights within this short span of time. So coming to the formal presidential address part of this today's event, I think the 3 topics the IEEE chapter has chosen for the celebration of the 2nd anniversary of your chapter all are related to the most advanced industrial developments that has been going on in the industries, and that is more linked to the 4th industrial revolution or the industry 4.0. So for the students who have been who are viewing this, I would like to give you a small stint on what is industry 4.0. You all might have learned about the 1st industrial revolution. So earlier, before the 1st industrial revolution, almost all the economies in the world, all the countries, they were all totally dependent on agriculture, and it was an agrarian economy. But things started changing when the first industrial revolution started with the invention of the steam engine. And then as years passed by, we had the second industrial revolution, where we aimed at the massive production of products in assembly lines. And many changes took part all around the globe when the second industrial revolution took its role. And then came the third industrial revolution, where most of us are right now in the third industrial revolution. Most of the industries in India especially are right now going through the third industrial revolution, struggling its transformation to the fourth industrial revolution. And the third industrial revolution, as you all have witnessed, many of us have witnessed, is introduction of the information technology, electronics, etc., to the and automation, everything to the industrial production. And then comes the fourth industrial revolution, which is very passionately called the Industry 4.0 right now. And it's already started taking its role in most of the industries and even in India. So what is Industry 4.0 is all about? It is interconnecting cyber physical systems. So already we are done with automations, etc. in the third industrial revolution. Here, what we are trying to do is we are connecting the machines and facilitating them to communicate with each other, so that humans can be more humans and do less work that machines, enabling humans to do less work that the machines are supposed to do. So we are giving all it to the machines, and humans have their own part to play with, because there are a lot of things in humans that the machines cannot replace even now. So this is all about the fourth industrial revolution, and it has started taking its role. And one such segment that will facilitate or is a byproduct of the fourth industrial revolution is the automation or the electrification of vehicles, which is the topic today. So what is the role of an engineering college that graduates a set of 400 plus engineers a year like UKF in Industry 4.0 is a big question here, because as you all are aware, the syllabus of engineering education that is being right now taught to you is almost in line with the education I had 10 years or 12 years back, or might be someone who is an engineer 30 years back. There has not much change that has been brought about in the syllabus to equip the students who are graduating as engineers and who are ready to go to industries that are adopting to Industry 4.0. So what UKF can do is that with this academic year, we are taking our very first step to something called the Engineering Education 4.0 at UKF, where we are aligning all our curriculum that is aligned with the affiliating university to a type that is being more aligned to the Industry 4.0, and also not just Industry 4.0, we would like to make it more meaningful, because we would like to help our students to know more about what are these 17 UN Sustainability Development Goals, what are the grand engineering challenges put forward, and all these things gives a meaningful education. And we want our engineering students not just to be students, but they can be student engineers as well. And as part of this program, we are also inviting a lot of industries to partner with us in different ways. So all these details are yet to be out, but I take this opportunity to announce this because I feel I won't get a better opportunity than this. Coming to the, I am not a very authentic person to talk about the electrification of vehicles, but from the little knowledge that I have, what I had understood is right now, India can be told as the sixth largest manufacturer of automobiles, especially cars, globally. And by 2025, Indian government aims to be in the third position in the manufacturing of automobiles, especially in the car segment. And one big leap that would help India to attain that target is through the electrification of vehicles. And as a person who travel, what I had witnessed when I had a small visit to Germany last year is that seeing an electric vehicle is no more a fancy thing in places like Germany or many of the European countries. I'm not aware of US, might be there also the situation is the same. So getting it is not more a fancy thing like charging stations, seeing a electric car running through the road. It's all like a normal, just like we see a luxury vehicle right now in our roads. So, but India has just started off its journey towards the electrification of vehicles. And what I had understood is Indian government has taken a lot of policies that would help in the massive electrification of vehicles. They have already coined an automotive mission plan 2016-2026 for achieving this. And also they have also set apart a separate independent department of transport. And also there is a national electric mobility mission. And there is also a policy called something called the FAME. And right now we are running in the FAME Part 2 mission. FAME stands for a faster adoption and manufacturing of hybrid and electric vehicles in India, which is a scheme that was started in 2015 to promote the use and production of electric vehicles in the country. And the government is also giving a lot of incentives to people who are going to use the electric cars. But the question is, are we right now ready for it? Whether the industries are ready for it? Many industries are taking their own initiatives for that. And what are the challenges and opportunities that we as a country and also globally have in the electrification? Because there are a lot of problems connected with the batteries, the charging stations, which is more reliable. All these things are coming up, the efficiency of the charging stations and so on. So right now we have a very, very eminent person, a very authentic person to talk to us about this particular topic, that is electric vehicles, its challenges and opportunities, both in India as well as globally. So let me take this opportunity to welcome the speaker of the day, Dr. Tommy Sebastian. So to give a short introduction about him and his credentials, Dr. Tommy Sebastian is himself an engineer who has did his BTech from Regional Engineering College, Calicut, right now known as the National Institute of Technology, Calicut, and he's also pursued his master's from IIT Madras. And also he has again done a master's and also pursued his doctorate degree from the University of Toronto, Canada. He has a wide experience working in the R&D centers of different firms, starting from Keltron, Trivandrum, and also many of the prestigious industries in the US, which includes the Black & Decker Corporation, and also the Delphi steering systems and Nextier Automotive. And currently he is, as you all know, he's the director of the motor drive systems at Hala Mechatronics in Michigan, USA. And with his IEEE contribution, I can tell Dr. Sebastian has done extensive research in the area of permanent magnet design and control issues and applications in steering system. And in 2003, he was elected as a fellow of IEEE. He's a recipient of the 2019 IEEE Nikola Tesla Award, which is a very prestigious award. And he was the general chair of the first IEEE Energy Conservation Congress and Exposition held in San Jose. And during 2017-2018, he served as the president of the IEEE Industry Application Society. I think it was a breathless credential that he has, very wonderful and very lucky for all of us to meet such a person like him. So I wholeheartedly, on behalf of the full UKF family and the IEEE UKF family, I welcome you, sir, to this session.
Thank you so much. Really appreciate it.
Yeah, so as a part of token of our love and appreciation, we would like to give you a small token of our love, a virtual memento. Right now, that's the only thing possible. So excuse us for that.
Thank you. I appreciate that, and I accept this memento. Okay.
Thank you, sir. Thank you. Thanks a lot. Yeah. So please take on. Yeah.
Oh, you want me to take over?
Yeah. Yes, sir.
Okay. So should I do the release of the?
Yes, sir. Yes, sir. Before moving on to the session, I request Dr. Tommy Sebastian to release the cover page of IAS e-newsletter, The Pulse. So please.
Okay, let me. Okay, I officially released the newsletter of IAS SBC UKF first edition, and it's called The Pulse. Thank you. Thank you for this opportunity for releasing this for the first time. Thank you.
Thank you so much, sir. Now let us move on with the session.
Okay, thank you. Let me also start by, the last few days, the news is coming from Kerala was not very pleasant news, whether it is the flooding or the flight accident or COVID or whatever. I'm sincerely hoping that anybody listening here has not personally affected by any of that. I express my sincere condolences to people who have affected by that. And I hope everyone gets recovered pretty soon. In the middle of all these things, and I think there are good signs and news we see, and I see the excellent work done by your IAS Student Band chapter to receive all these awards. And I had the opportunity to meet some of you at the last year's IAS annual meeting, and I was hoping that we could meet some of you at the annual meeting this year, but unfortunately it has become virtual, and we will have to do it virtually. Otherwise, we could have received all these awards in person in Detroit, which is only 100 miles south from my place. So it would have been good to meet you all there, at least some of you there. But unfortunately, this year we'll have to do it again remotely. But I think that doesn't diminish the amount of work you guys have done and the great achievements you have made. So congratulations to the whole team for the excellent work. And also, I recently heard about the news, the publicity I saw on some of the students who developed the solar lighting systems, and it's great to see such achievements from the students, and congratulations to the students involved in that one too. Great work, keep it up, keep up the good work. I think it's nice to see all these things in the news too. Thank you so much for all that great work. With that, let me start my presentation, which I was supposed to do. Before I start, let me say a couple of words about where I'm working and what I'm doing. I am working at a company called Hala Mechatronics. We work on motor and control issues, and motor control we call it as power packs for various automotive applications like steering and braking and propulsion and everything. So I spend a lot of time in developing the system, motor and control systems for the electric power steering system, which I'll talk in a few minutes. So that's the background. But where am I? I am somewhat in the northeast part of United States. If I go a little more zoom in, we are actually surrounded by the Great Lakes. Those who have studied that, there are 5 of the Great Lakes, which are the largest freshwater lakes in the world. So pretty much we are surrounded by these 5 lakes. And the IAS annual meeting was supposed to be held in Detroit, which is just, if you can see my cursor, it is supposed to be somewhere here. So we were supposed to be meeting there. Unfortunately, we will not be meeting this year. So when we talk about electrification, actually, I should mention one thing about the first hydroelectric power plant was in Niagara Falls, which was installed in 1881. Niagara Falls is really a waterfall from Lake Erie to Lake Ontario, and the Niagara Falls is located somewhere here. So for those who are not familiar, this line is the boundary of Canada and US. Canada is the north of this, and the south is the US. So, and the Toronto is somewhere right here. Okay, so it's so with that, let me talk. When you talk about electrification, now first thing come to your mind is probably the electric vehicles. But if you look at the whole world today, we have about 1.4 billion cars running around the globe. Out of which, if you look at the electric vehicles, it's only about 3.2 million in 2018. I think we put another less than 2 million in 2019. So we are somewhere around 5 million battery electric vehicles running in the world. So if you look at the percentage of electric vehicles, it is still very, very small, but it's a very, very large growing market too. But the point I was trying to make was, now when you talk about vehicle electrification, there is more and more things happening in the vehicle other than the electric vehicle also. So we will cover both of these aspects today in my presentation. Now, see, the first mass-produced vehicle or the car was the Ford's Model T, which was introduced in 1908. The extent of electrification in that car was really a 6-volt battery and a dynamo, which is nothing but a DC generator and a couple of lights. That was the extent of electrification in the cars. And in late 1940s, the 6-volt battery changed to 12-volt battery, and even today most of the cars which we see have a 12-volt battery. But they sold about 15 million of these cars in the 20-year time frame in the early 1900s. So from there we have come a long way in terms of electrification of the vehicles. So from the 6-volt battery and dynamo, today, if you look at the car, there are so many things which are electrical. You're all familiar with the navigation systems and the human machine interface systems. And the electric power steering is another electric things which we introduced a few years back. You have anti-lock brake systems, tire pressure monitoring systems, even heated steering wheel and heated seats, which are needed in places like here, we can become very cold. Electric water heater pump and cabin heating, air conditioning, and with the introduction of all the hybrid and electric vehicles, we have the motors and the chargers and inverters and converters, DC-DC converters. I mean, all these things are increasing in the vehicle. So today, the electrical content in the vehicle has grown up significantly over the last several years. Now, so the electrification and advanced control in the vehicle are accelerating at a much faster rate. It is not stopped yet. I mean, we are seeing more and more electrical stuff happening in the car. Now, why are we talking about electrification? No, what was wrong with the good old way of living in the car, having the car? No. So what is the electrification bringing us to the vehicle? To me, it has 3 or 4 elements, basically. One is the safety aspects. Second one is the fuel economy and emissions. And the third one is, of course, the driver comfort and convenience. So these are the elements which are driving the electrification activity in the vehicle. So let's talk a little bit about the safety aspects. Now, if you look at the car, there are a lot of things in the car which are there to protect the driver in case of an accident, like the airbags and the seat belts and all that stuff is there in the car to protect the driver in case of an accident. That doesn't do much if there is no accident. So the next safety trend is really the things which are there to avoid the accidents. They are really passive elements. For example, you have what is called the lane departure warning systems now out in several cars, where if you are going on a highway with multiple lanes and if you're drifting from lane to lane, which is a sign that maybe you're sleepy or something, and the car can detect that you are drifting from the lane and warn the driver or shake the steering wheel or the seat to wake the driver up. So that will put the driver back in control really, and to avoid the accident. Same thing with the driver human factors, like if you can monitor the driver's eye and see that the driver is sleepy, and he can warn the driver that you are sleepy and get up. So again, that is another way to avoid the accident. Another thing is driver distraction. If your hand is not on the steering wheel all the time, the car can detect that and again warn the driver to put your hands on the steering wheel, for especially on a straight highway when driver can be distracted and take the hand off the hand wheel. So these are some of the things which are there really to avoid accidents and help the driver to take charge of the vehicle. So again, these are the things which are there in today's car. Quite a number of cars have this type of features. The next generation of the safety systems are when the car starts doing the safety activities by itself rather than the driver doing it. For example, the adaptive braking systems are going to be, these are also some of the available in several of the cars. Adaptive cruise control and braking systems are really, if the car in front of you slows down, your car has to automatically slow down. So without even the driver getting involved in that one. So now you see that the car is now getting involved in the active safety type of activities, so which will make the vehicle much more safer. So now, in order to do all these things, with the good old car, we are not able to do these type of things. With the electrification is allowing us to do all these things. I'll talk about it a little more in a few slides. Now, one of the main element of the result of the electrification is the autonomous driving. In autonomous driving, now the Society of Automotive Engineers have divided the automation, the level of automation into 5 levels, six levels actually, level 0 to level 5. The level 0 is absolutely no automation versus level 5 is complete automation. That means, the car can go from point A, anywhere in point A to point B without the driver getting involved in that one. Today, of course, we don't have a level 5 type of car available. I think it's going to take a lot more time to get to the level 5, which needs infrastructure and vehicle-to-vehicle communications, vehicle infrastructure communication. All this has to develop much more. We are probably somewhere in the level 2 to level 3. Today, we have cars which can really go autonomous in highways. If you take Tesla and Cadillac, say some of the Cadillacs and all that, they can do automated steering, automated driving on the highway from entry to exit of the highway. And even on the city driving, they can do some level of automated driving. But today, the laws and regulations of the most of the countries doesn't allow the car to take complete control. Even though the car can take complete control, driver is supposed to be in charge of it. So if the accident happens, driver is responsible for that. So that is why we are still we are capable of going. Some of the cars are capable of going up to the level 4, but I think we are somewhat restricted to level 3 because of the legal limitations also. So I mean, I have driven autonomous driving cars, which can even change the lanes in the highway automatically and go from point A to point B. So Tesla can do that today. So again, these type of activities are possible only because of the electrification. Now, one of the aspect of all this work is mainly, to eliminate this type of sceneries, what we see on the roadsides. You see all these accidents, which most of them could have been prevented if the vehicle was taking active control from the driver and take the vehicle to the safety level. So our hope is all this work will put an end or minimize these sceneries which we see on the roadsides. Now, if you look at the fuel economy and emissions aspects, one of the things which I want to just point out is industry transformation that happened in the last couple of decades. When I started working in the automotive industry, if you buy a car, mostly you're buying a car with a hydraulically assisted steering. In a hydraulically assisted steering system, when the driver steers the steering wheel, there is a valve mechanisms that opens, and there is a high pressure, there's a pump which creates high pressure fluid, and that high pressure fluid is pumped into a cylinder and piston arrangement and pushing that high pressure fluid helps the driver to turn the steering wheel much easier. So this was the technology of the time at that time. Since then, if you buy a car today, you are buying a car with what is called the electric power steering, where we have a motor and a controller and a sensor and a mechanical gearing mechanism, which provides the assist to the driver. So there's no more hydraulic fluids and hydraulic pumps and everything in the car for the steering systems. So the car industry has completely pretty much moved from the hydraulic to the electric today, except for some of the bigger cars where the battery power is not sufficient to assist the driver. They still have the hydraulic systems in such cars. But other than that, mostly if you buy a car today, they are all electrically assisted steering systems. Now, you can see also along with the let me see, if in the hydraulically assisted steering system, the pump is connected to the engine. So as soon as you turn on your engine, your pump starts running. If you are going on a highway when you really don't need to steer anything, if you're going on a straight highway, the pump is running continuously and creating losses. Whereas in an electric power steering, the motor turns only when you steer the car. If you don't steer, if you're going straight, you are not producing any power or you're not losing any power. So your power dissipation has significantly reduced. So if you compare a hydraulic vehicle with hydraulically assisted steering versus electrically assisted steering, the fuel economy savings is anywhere from about 0.5 miles per gallon to about 2 miles per gallon, depending on the vehicle. Size of the vehicle. So that is a significant improvement. And since the introduction of the electric power steering, I think we have saved millions and millions of barrels of oil because of the fuel economy savings from the electric power steering. Of course, the other good example of electrification is the electric vehicle. In this electric vehicle, you have the batteries and the motor and controller. We pretty much eliminated all the IC engine and all the most of the hydraulic stuffs too. We eliminated in the electric cars too. Now, when we talk about the electric cars, this is the picture of a Tesla Model S car. See, you can see that the front compartment where the engine used to sit in a conventional vehicle, now they have created space for putting your luggage and stuff. You can see that the space is now used for carrying your luggage. So what happened to the engine space? Engine space is now being used for much better usage. Now, what is the challenge for the engineers? We need to package all our motor and controller, which is driving this vehicle at a space which is behind all these things. That means, much smaller space. You have to package everything into much smaller space. So you have to design your systems to much more efficiently to make it smaller and package it without anybody seeing it. Even though we engineers are very proud of these motors and controllers, so nobody cares about that. They want their space for carrying their stuff. So we'll have to package all that stuff underneath somewhere else. So that is a challenge for our engineers now. So when you talk about the packaging space, what is a space which is not being utilized properly? Is it it's the wheel, inside the wheel? There are a lot of empty space. Can I use that space for packaging all my motors and controllers and everything, so that I can use that engine space for something else? That's what is called the in-wheel or corner module type of work. There are a lot of work going on in this. In this case, inside the wheel, we have packaged the motor and controller, and not only that, the motor and controller for driving, it also packs the braking systems and the suspension systems and the steering systems, and everything is integrated into this corner module. Of course, this is great advantage in terms of how we can effectively and efficiently utilize the space. But the challenge is, of course, you have to package all these things into a small space, and also into a space which is not very environmentally friendly. You have to package all these things where there is water and mud and everything going to be going in. And so how do we package all that stuff? And that is the engineering challenge for all of us to figure it out. Of course, these things are not in the market yet, but a lot of work going on in this area. The driver comfort and convenience wise, as I told you that this is the electric power steering few configurations. Let's look at the middle one. When the driver steers the steering wheel, there's a torque sensor which senses the torque and put the give the command to the motor to provide the torque to assist the driver. That's how it works. Now, if it is a hydraulically assisted steering system, you always need the driver to turn the steering wheel to get the assist. Whereas here, with the electric power, the introduction of the electric power steering, I can steer the car by commanding the motor without even the driver touching the steering wheel. So for example, if you want to do automated parking without the driver touching you probably have seen some of the videos of the automated parking systems. I avoided all the videos because I don't know whether it'll work very well through the remote presentation. So, but in the automated parking, you can command the motor to steer the steering wheel so that you can control and park the car. And also for automated driving, without the driver touching the steering wheel, if you want to drive the car, you still have to steer the vehicle, and the steering can be done by commanding the motor to steer. So the electrification is the one which allows us to make these vehicles automated driving and automated parking and all that stuff. So to make the life of the driver convenient and comfortable. And these are the elements. Of course, this is the picture of a Google car which was driven automated driving in California, which got a lot of publicity some time back. So this is the driverless cars. Now, you also probably have seen some of these things in the news. This is a car which they're trying, self-driverless car, but self-driving car for the taxi, which is a company called New Autonomy in Singapore, introduced some time back, and they are still testing with this thing. Again, another example of electrification, the taxi flying over Singapore, which is again electric traction, completely electric air taxi. Again, last month, IEEE Spectrum, if you probably saw some of the things which are happening, the electric drones which are carrying stuff from ships and planes and things like that, and inflatable e-bikes. Again, this is a good example of electrification of even the bikes in the cars. Now, with all this electrification, there are a lot of challenges, and for engineers, really, each of these challenges are opportunities too. Let's talk about when we go into the pump petrol station and pump the gas or petrol. Have you ever thought about the power transfer we are doing? If you think about a 50-liter pumping of 50 liter of petrol, if you look at the energy we are transferring when you are pumping that gas, is about 1600 megajoules of energy we are transferring. And let's say you take about a few minutes to pump that gas, petrol, and you can see that, the energy divided by time is the power. And if you look at the power, it's about 9 megawatts of power we are transferring when you're pumping the gas station, the petrol. You probably have never thought about that one, but that is what really happening. Now, when you talk about electric cars, and if you want to get the same performance like a petrol or diesel car in terms of charging capability, we are talking about a charger of 8.9 or 10 megawatts to get to the same time charging, which is probably not a practical thing to do. But I just want, and if you take the Tesla Model 3, they have a battery pack of 85 kilowatt hour, which is about 306 megajoules. Compared to the 50-liter gas, it is much less, but we have the advantage that the IC engine, which is the efficiency is less than 20%, whereas the electric cars and electronics has much higher efficiency. So you can get probably a similar range of driving with the batteries, which are much lower in energy compared to the petrol tank. So this gives. So if you look at the charging capacity, the x-axis here is the charger capacity in kilowatts, and the y-axis I have two things. One is the charging current and the charging time to fully charge same as the Tesla Model 3 battery. So if you have a 1 kilowatt charger, it takes probably a couple of days to charge that battery. It takes a long time. So if you look at most of the cars, electric cars come with an onboard charger, which is, they call it as a level 1 charger, which is less than about 1.5 kilowatts. It takes a couple of days to charge the battery with, or even more, to charge the battery with that charger. Now there is what is called level 2 charger, which is about 3 to 20 kilowatt type of charging. This is an external charger. With this one, you can probably charge overnight or slightly more than that. In about 10 hours or so, we can fully charge the battery. Again, it's an overnight charging. Think about, compare it with your petrol pumping in 3 minutes versus the pumping here overnight. Now, the level 3 charger, or sometimes it's called the supercharger, is about 100 to 150 kilowatt, which really gives you almost 80% of the charge in about less than half an hour. So even with this one, you are talking about half an hour for charging. So you think about a pump station or a petrol station replaced with a electric charging station. You are still talking about 100 to 150 kilowatt for each station. And if you have 10 charging stations, we are talking about 1.5 megawatt charging system there, which is going to be a challenge. So really, speaking, how do we manage all these charging centers, and how about the charging time, and what is its impact on the charging stations, even for commercial power systems, like, if you have a big company, they have their own power systems internal, and they have to provide charging stations for the employees, and what is its impact, and the sudden charging and discharging of the charging and stopping of the charger, what is its impact on the power system. These are all issues that needs to be tackled. And of course, the other issues really, when we talk about electric vehicles, we always think about, it's a zero emission vehicle. Is it really zero emission in terms of the impact on the emissions in the emissions? If the power you are receiving to charge the electric vehicle is coming from renewable energy, yes, it is very much emission-free system. But if the power is coming from a coal-based or gas-based power station, then you are really moving the emission from one place to another place, which we are not really addressing the real emission issue. So unless the grid is mostly based on renewable energy, the impact on the emission is all relative. So some of the places in Europe where quite a bit of power is coming from the solar and wind energy systems, there is significant advantage in with the electric vehicles there. The other challenge is the battery. If you look at the electric vehicles, the biggest challenge, in addition to the charging time and charging issues, is the battery. The cost and the weight of the electric vehicle today is mainly dominated by the batteries. So there is a lot of work going on in the battery sector in terms of reducing the cost and in terms of increasing the energy density so that we can make it smaller. I'm not an expert in the batteries, but I can see that there's different technologies are being worked on, and the expectation is that the cost of the battery is also coming down significantly over the next 10 years. We don't know. I do not know which technology is going to win at the end of the day in terms of being able to increase the power density and being able to charge faster. Some of the challenges in terms of for engineers like us, what are the challenges in designing this generation of systems? We have to develop systems which are highly cost effective, because you can develop all these things. If it is very expensive, nobody will buy it. And as I said, how do you package all these things into very small areas? And how do you make the systems more efficient? When you talk about efficiency, normally we think about, if you look at the electric vehicles, we think about efficiency is related to the driving range of the car. But in addition to that, really speaking, if you can make the efficiency higher, you are reducing the losses in the machine, and you are able to manage the heat in the car much easily. Heat dissipation and management of temperature and power loss is a huge issue in the car, and that's what making this packaging much more bigger. So if you want to pack it very small, if the losses are lower, then you are able to package it very, very efficiently. Now, we also have to start thinking about the fault tolerance and diagnostics capabilities. I showed you the picture of the electric power steering. If you take a car, if the electric power steering fails, the driver can still steer the car because the driver is mechanically linked to the road wheel, and he can still steer the car. Of course, he has to put much more effort, but at least on a highway, when you're going at high speed, the loads are lower for the steering, so the driver can at least bring the vehicle to a safe state to the roadside without creating a huge issue. But think about an autonomous driving system. When the driver is not in the loop, if the steering fails, you are bound to be in an accident. So the failure modes which was acceptable before is no more acceptable in the next generation of vehicles when we start talking about autonomous driving and autonomous steering. So the picture I am showing here is a picture of a steering controller which is in production today for a car which uses the autonomous driving and autonomous steering. So how did we manage that one is really by putting redundant systems. If you see that, you can see a duplication of same thing twice here. So there are two controllers which are controlling the motor which is driving the steering system, and if one goes down by any reason, the other one takes over, so that the vehicle is still controllable and active. So these are some of the ways we are addressing the safety aspects in the next generation of vehicles. And you can also see, just for those who are in the power electronic side, these are the power electronic FETs, which are the switches which are controlling the motor, and these are the two digital signal processors which are controlling the brain of the control of the motor and the steering systems. The fail-safe operation and diagnostics capabilities, and another things which are going to become important is also the self-diagnostics capabilities and the smart devices, because we want to know before something fails that it's going to fail, so that we can take corrective actions beforehand. So how do we monitor the health of the devices so that we know that something is going to happen, something bad is going to happen before it happens, so that we can take corrective actions. And audible noise and high temperature operations are all important, because in the car, when you are steering the vehicle, you don't want to hear noise from the motor or controller, so you need to design the motor controller to minimize the noise. And higher temperature operation helps to, I talked about the efficiency and all that. How do you manage the temperature? If I can afford to go higher in temperature with the devices, then I can make again smaller package sizes. Now, why is this all this electrification? I told you what are the driving factors, but why didn't we start doing this electrification before? Why is it happening now? I think several elements which are driving these things is, one is really the significant improvements in the power electronics capabilities today. So you are able to do all this control of the motor and all that stuff. You are able to do effectively. The motor control switches which you are using, the power MOSFETs have improved significantly, that when they are on, they are actually like a conductor, so there is very minimum losses. And there are new switches coming up for high voltage type of applications, what is called the wide band gap devices, like gallium nitride and silicon carbide, and all that devices are coming up, and they are improving the performance and reducing the cost. Even though it is more expensive today, it is expected that the cost is going to come down, and we are going to be seeing more and more of these things introduced in the cars. Another thing is significant progress in the processing and control capabilities. when we started working on the electric power steering, we were working with an 8-bit microprocessor. Today, we have a digital signal processor which can do any computation we want. We can do complex field-oriented control of the machine or the steering system control or any of these things. We are able to do all that stuff with the digital signal processor. You tell me what math you want to put. No, I'll be able to put that in the digital signal processor. So this is a huge element. And I talked about, I didn't go into too much details about that active safety systems. Think about a condition where the car is going to roll over, and if I can sense that information and process that information faster and take corrective action faster, I can bring that vehicle to the safe level by appropriately steering or braking. I can do that. I can only do that if I have the computing capability and processing capability, which I can do in milliseconds and get the corrective action immediately so that I can bring the vehicle to safety. So these are all elements which are possible because of the significant progress in these processing capabilities. Of course, the electronics cost is another major factor, and the machine and the motor winding and motor manufacturing and motor new magnets and all that stuff is also improving the size so that we are able to package all these things into a smaller space today. And another major aspect is really, the efficient analytical tools for design optimization. Today, we have all these finite element tools and everything in terms of designing machines and even the power electronics and the electronics devices. We are able to do all the design work properly so that we know when we make the hardware what is going to happen, and we are able to optimize every element of it. If it's a motor, we are able to do the analysis to find out where is the flux maximum and minimum, and minimize the magnetic material so that the weight and the size of the machine can be minimized. So the advances in these analytical tools is giving us ability to design the systems much more efficiently and optimize design. We are able to do it today. So in all these things, what is our role? Our role as we sometimes put ourselves into boxes like electrical engineer or mechanical engineer or chemical engineer, or even inside that, machines engineer or power system engineer or control systems engineer. I think in order to design the systems, what is needed for the next generation of applications, we all will have to start thinking about as a systems engineer. If I am a control systems engineer, I need to understand the system before I can start designing the control systems for that. If I am a motor engineer, I need to understand the system so that I can optimize the design to meet the requirements of the system. So we all have to understand the system very well before we start designing the individual components. At the same time, I also have to emphasize the fact that, if you talk about the undergraduate education, we are all putting the basics in the undergraduate education. So in order to work as a systems engineer, even though you are a mechanical or electrical engineer, you need to understand the other systems, the mechanical side, the structural side, the chemical side. So the basic education has to provide that basics so that we are able to, even though we are not an expert in each one of that, so we are able to understand the impact on the other systems. So, I heard in the presidential address today, we are trying to revamp the basic education curriculum. I hope we are not taking out all the basics required to understand all the systems in that process. So, because you can always specialize when you're going to do a graduate study or, PhD or master's, and you can always specialize, but the undergraduate education has to provide the basics for everything so that we can understand the effects of all these things in our designs. So we have to integrate all these things into the mechanical or electrical or all these systems to ultimately provide the systems which are useful to the end user, whether it is in electric vehicle or in other systems. Ultimately we need to design the systems which are cost effective and useful to the end user. So to conclude my talk, last 10 or 20 or 30 years, we have witnessed tremendous progress in in engineering and technology in terms of whether it is communications or medicals or transportation or social media, all these things. We have seen tremendous progress in all these areas. We have seen technologies even coming in and dying out in this time frame. And I still remember when I came to North America for my graduate studies, that was the first time I heard the word facsimile or fax. Um, I was amazed that we are able to send a piece of information on a piece of paper from one place to another place without somebody taking it manually and giving it. That was amazing technology at that time. That technology came and went. I'm sure some of you might not have even heard of fax now because it has become obsolete. Today, I am able to sit here in the other side of the world and talk to you all two-way communication, basically, without even milliseconds of delay, let me say. Okay, so if it gets a little delayed, we get impatient today. So we have seen all these tremendous changes and in terms of all these technologies, and so what is going to happen in the next 20 years? To me, in general, I would say, it's a good time to be an engineer because it is exciting to be a part of this next generation technological revolution. I mean, I was glad that I was part of the revolution in terms of transforming the steering industry from hydraulic to electric. And I mean, there are several others were part of a lot of these transformations. And, in the next 20 years, what is going to happen? What defines the next 20 years? I think, you all have a part in that one. It's up to you to define what are the things which is going to happen in the next 20 years. I think, I would not be able to predict what is going to happen in the next 20 years, and you will all define what is that. And I'm sure 20 years back from now, we will be sitting back and say, no, okay, I didn't even think that this is possible at that time. So I think you all will be playing a major role in that. And I think I'm looking forward to seeing the developments in the next 20 years. And I wish you all the success in everything. Thank you. And I think I will stop it here, and I will hopefully be able to answer a few questions from anybody. Thank you. So how do you want to manage the questions?
Sir, Suja ma'am will take over from there with the question session, I think so.
Let me.
We have some really good questions, from the registration. So we'll point to them with this minimum time.
Yeah, go ahead. Yeah.
Okay, sir, I think Suja ma'am got disconnected because of the network issues are still there in Kerala, many places. So hopefully she
Okay.
will join us soon. So in the meantime, I will start with the questionnaire. So
That'll
one
be
question
fine.
we have received is like, yeah, while electric vehicle come into being, how will it challenge the existing gasoline industry and how they can also coexist?
Okay. Let me also say that really electric vehicles, as I said, is still a very, very, very small percentage of the cars as I started my talk with that one. So the coexistence is going to happen for a long time to come. I think, there are predictions, even I think the India government had a plan to have significant electrification by 2030 or so. But we will see how far it'll go. Because I think we have a long way to go for complete electrification, especially in India and places like that, because the infrastructure has to develop. So we really do not have a infrastructure in place to be able to drive the electric car everywhere, because and in Europe and places, I think it has grown much more in terms of the charging infrastructure. In US, if I take, companies like Tesla has taken the lead in putting the infrastructure in major highways, so that if you take a Tesla and drive, it will tell you exactly where are the charging stations available, and it will warn you saying that no, the charging station is within this range and you need to go and charge it because your battery level is low, etc. So that type of facilities are available, but still, the range anxiety is still a part of life for the electric vehicles still. Even though we have come a long way, I think we still have a long way to go in terms of the proliferation of the electric vehicles to a mass audience. And the other factor is really the cost aspects are still high. Even though, I mean, again, if I take Tesla, when they put their first systems in the market, it was about $100,000 more, actually $130,000 type of car. And the recent Model 3 they introduced is they brought it down to about $35,000. So that's a significant reduction in the cost of the vehicle. And so it's becoming more and more in the affordable range. So again, still it is considered as a luxury car rather than a common man's car. So still we have some way to go before we see the full electrification. I think it's going to take at least next 10-20 years before we see a majority of the vehicles being electric vehicles. So I think the coexistence is going to happen for at least for some more time.
Okay, sir. That's nice. That's well answered. Actually, we have a related question now. The question is like, sir, if there is an increase in the EV in this very near future, then obviously there will be a rise in the demand also for electricity, right? That's obvious. So obviously we need to have a boost in the power production also to meet the demand, which we are in turn raising the use of fossil fuels, because the hydro is having its limits and also the renewables is a solution to meet the demand.
Yeah, good question. I mean, I think I covered some of the issues in my presentation because we always say that electric vehicles are zero emission vehicles, but it is really not zero emission vehicle if you are charging it from a grid which is coming from coal and natural gas. So really speaking, unless there is a transformation on the grid to have more and more renewable energy sources, the emission aspects we are really not addressing. Okay, so that is one issue. Again, that is, India is making a lot of progress in terms of introducing solar systems. I think somewhere in the north they have introduced. They're planning to put a 1 gigawatt system, solar system. So that is big. NTPC is doing, I think, is so. Excuse me. So these are all good signs of introducing more and more renewable systems, but the renewable systems have its own disadvantage in terms of the variations and the fluctuations in the availability of the power. So that introduces a new challenge in terms of storing of this energy. So how do you store? Are you going to use battery systems, or what type of systems are you going to use to store the energy so that we can get that renewable energy when you want it? So these are all power system challenges which are being addressed today. A lot of work is being done in terms of how do you manage all that stuff, and how do we increase or how do you reduce the dependence on the coal and such fossil fuels. So again, for engineers who are working in that area, there's a lot of challenges to address, a lot of issues to address, and a lot of issues on the. I mean, you see a lot of activities in the smart grids and smart grids and smart activities on the power systems being done. So that's a good area to be working in also. Okay.
Thank you, sir, for that explanation. And next question is is it really possible to completely replace the combustion vehicles in future at least?
Is it possible? Everything is possible, I think. But when it is going to happen is the question mark. Whether it is 20 years or 50 years, I don't know. The time will tell. I think, if you look at all the predictions, that there's at some point all the fossil fuels are going to run out. So we'll have to depend on the renewable sources, and then at that time probably everything has to be electric, I guess. So I don't have a crystal ball to tell you when it's going to happen.
Okay. And one more question is there. Which is most effective or efficient in performance? Is it the hybrid vehicles or electric vehicles?
Hybrid or electric? What is the question?
Which is most efficient in performance?
I'm not sure what is meant by efficient in performance. Let me see what I can answer that one. So if you look at the efficiency of driving electric vehicle, has the advantage, because the IC engine always has the smaller efficiency of 20% or even less, and so we have a disadvantage from that point of view. So the electric vehicle has that advantage. But the hybrid vehicle, in my mind, has the advantage from the point of view that you can get rid of that driving range anxiety, because you can pretty much, especially if it's a plug-in type of hybrid, anybody who is driving, let's say 10 miles a day or 20 miles a day, he can pretty much drive that car as a electric vehicle. But the day he wants to drive 100 miles or 200 miles or 300 miles, he can still drive that vehicle, because he can drive it as a IC engine based vehicle. So that takes care of the range anxiety issue. But now you complicated the system with the electric vehicle and the IC engine type vehicle, so it becomes more challenging to incorporate all these things, and becomes more expensive too. So these are really the real life challenges which we have to face before we can say no, one is better than the other. Today, with the charging infrastructure unavailability, a plug-in hybrid is probably a good option in most of the cases in terms of being able to drive mostly as an electric vehicle.
Okay, we'll move on to the last question, sir.
Okay.
Do electric vehicles all over the world will be an over-advancing to the existing resources? Means will it be too much to the existing resources?
I'm sorry, ask again, or will the?
Do the electric vehicles all over the world will be an over-advancing into the existing resources?
Over-advancing, I'm not sure what it means.
Can the existing resources sustain, I mean, take up the need of all the vehicles all over the world?
Okay, I think he's talking about the power system capability. Today,
Yes,
if
right, sir. Right, sir.
yeah, if we transfer, if you tomorrow morning you wake up in the morning and say no, we are going to make everything electric, I think we will have a huge problem with the power systems, because I don't think the power system is capable of doing that today. But as the time goes, as the penetration of the electric vehicles gradually increases, the power system capability also has to increase to accommodate that one. So I think these activities will have to happen in parallel, so that we are not creating a huge problem on one side when you're addressing the problem on the other side.
Thank you, sir. Very good explanation. And that was the last question from the participants. And we are coming to the end of this session. And now I invite Ms. Alfina, the chair of IAS SBC UKF CET, for the vote of thanks.
Thank you, Suja ma'am. Am I audible?
Yes, very well.
Honorable
Yes, you are audible.
Honorable dignitaries, distinguished guests, respected director ma'am, and dear participants, on the behalf of IEEE Industry Application Society, Student Branch Chapter UKF CET, its entire fraternity and the organizing committee, I feel immense pleasure to propose a vote of thanks to our eminent speaker, Dr. Tommy Sebastian, President of IEEE IAS for the year 2017-18, who spared time from his busy schedule to grace this webinar with his extremely insightful address on vehicle electrification, challenges and opportunities. I would further extend a hearty thanks to our beloved director, Mrs. Amrita Prashop, for her unfaltering support and confidence in us. I take this opportunity to specially express my deep regards and gratitude to Mr. Sumod Sundar, Councillor of IEEE SP UKF CET, for always encouraging us. I would specially thank Mr. Adul MB, Advisor of IEEE IAS SBC UKF CET, for motivating us and providing opportunities to organize such events. My deep sense of appreciation and thanks to all the participants who chose to be live with us and attended the webinar with great enthusiasm and made it a successful event. I extend my sincere gratitude to Ms. Sujan Nair, Head of Civil Engineering Department UKF CET, for moderating the session. Last but not the least, I extend my thanks to all my fellow volunteers who actively worked behind the successful conduction of the event. Once again, I thank you all for being with us this afternoon. Have a wonderful day ahead. Thank you.
Thank you, Alfina. And
Thank you, Arun.
here we are
Thank
winding
you
up the
so much,
session.
sir.
We have great
Excellent.
challenges. We have great challenges and great opportunities. We will meet them and make them the best to our history. Once again, thanking everyone for your time. Thank you so much.
Thank you.
Thank you. Thank you, Tommy, sir. Thank you so much.
Thank you very much. Yep.